growth or decay. It's a lot like the end of 8.7, just a little bit different of a formula. Let's jump in. The problem set is just 10 and 12. Make sure that you do these ones as well, and then 10 and 12. So 8.8. It's all about word problems. Can you distinguish whether it's exponential growth or decay? But if you notice, we're dealing with natural logs again with this exponential growth and decay. But here are the two formulas. Exponential growth, f of x equals a times e to the kt, where a is the initial value, t is the time in years, and k is the constant representing the rate of continuous growth. Exponential decay is the same exact thing, except it's a negative k times t. That creates the decay part. I'm not going to go through this example so much, whether I like the second one more, but this one right here is exponential growth. So I'll just get started. Exponential growth. And it says that we are investing in an energy ETF of $15,000, and it increases at a rate of 7.5 per year. Find the value after 30 years. So the first thing I want to do every time, what's my little a? Do I know what my f of x is? This I don't know. A I know is 15,000. My rate is 7.5%, and I need to change that into 0.075. And then my time is after 30 years. This is the most important of them all. Can you give me this? Can you give me what each part is, and then put it into the function? So you would have f of x equals 15,000 e to the 0.075 times 30. And then you could just solve this. And I believe that you should get, if you try it out, $142,316.04. But I want to go into more of an exponential decay version. So here we have a new car that sells for $18,000. It depreciates at 25% each year. Write a function that models the value of the car. Find the value of the car after 4 years. And then I have a little hint that for pure value wise, we'll see that it's actually better to buy used than new, and that's just pure value. That doesn't go into any sort of if it needs mechanics, does it need replacement parts being used, just pure value of the car. Here, first things first, this is the model, the formula, whatever you want to call it. F of x equals a times e to the negative kt. Our a, our initial value of the car is 18,000. Our k, now we used to think that was just r, but our k is the same thing as r, it's just whatever, it's depreciating by 25%, which is 0.25, and our time, it says about after 4 years. Now sometimes problems will give you the exact k, or they will say find the k first, and I'll show you how to do that. But now, we just plug everything in, so we have 18,000 times e to the negative 0.25 times 4t. Now my first things I want to do is simplify up here. So I have 18,000 times e to the negative 1. 0.25 times 4 is 1, and then times negative 1 is negative 1. E to the negative first power. Grab a calculator really fast. And there, that's e. It's second ln. That gets you the e. And e to the negative first is 0.36787. You multiply that with 18,000, and you get a final answer of $6,621.83. This is the value of that car after 4 years. So if you're thinking about, okay, how much money is the car losing? Started at 18,000, now it's 6,000. So after 4 years, and this isn't really a part of the problem, but after 4 years, the car lost $11,378.17 in value. So just the thought of pure value, how much is this car losing? All right, so that's not really about the problem, it's not what they're asking. This is what they're asking. It's just this is kind of looking into it a little bit more. But now I'll flip the page. Give another little example. Then we have the distant growth function. And the example, so they're going to give you in examples and on the assessment, I'm going to assess you, I'm going to give you something with numbers involved here, and then can you use those to find whatever they're asking you to find. So for this example, you are a forester. The population of trees in the forest near Navarino follows the function f of t equals 18,000 divided by 1 plus 16e to the negative, and then this is all in the exponent. So this is all together in the exponent, a little typo, where t is the time in years. So it does say graph. I won't have you graph anything. But B is what I'm more worried about. And this says, when does the population reach 17,500 trees, which is approximately the amount of trees needed to make the maximum profit for logging. So you can imagine yourself as a forester, and your data analysis for the forestry or the DNR or whatever, and you're trying to figure out when is going to be our maximum profit amount for logging. We know that that's at 17,500 trees. We have this formula. Let's use it. All right. So here we have f of t equals 18,000 over 1 plus 16e to the negative 0.084t. Just like that. Now, what we have here, we have to decide, are we looking for the amount of years, or are we looking for the total amount of trees? And it says when. When means what time, right? When, how many years? So we're looking for t. We don't know what t is. What we do know is what we want the population to reach. We know what f of t is, and that's 17,500. There's two options. Either you're looking for f of t, or you're looking for t itself. We're looking for f of t, so that now we have 17,500 equals 18,000 over 1 plus 16e to the negative 0.084t. Now this is where you're going to use a lot of your algebra skills here. But I can't do anything with this side. I can't do anything with this side. I need to get this, the 1 plus 16 times e to the negative 0.084t to the left side. I have to get away from being in the denominator. I can't do anything with it. So I'm going to multiply it on both sides. So once I do that, I'm going to show my work over here now, is I now have 1 plus 16 times e to the negative 0.084t. That's all multiplied with 17,500 equals 18,000. What I can do here is that there's multiplication going on between these two parts. I'm going to divide away the 17,500. And I have 1 plus 16e to the negative 0.084t equals 1.029, we'll say. Now I haven't done anything with exponentials yet. Now I'm just trying to solve. I'm trying to get e by itself, what we talked about in 8.7, getting e by itself. So I'm going to subtract 1 here. So now I have 16e to the negative 0.084t equals 0.029. I then can divide by 16. I have e to the negative 0.084t equals 0.0018. So now we're here. Now that I have e by itself, I can do what? I can ln both sides because that gets rid of the e. So when I ln both sides, and I say ln, I multiply ln on both sides. We ln both sides. Once you do that, you have t equals ln 0.0018 divided by negative 0.084. When you do that in calculator, it will come out as 75.33 years, which is kind of cool because it means that you found out when we're going to meet our maximum profit. It'll be in 75 years. Then this forest will be ready to log. All right, so then the two filing questions you have for homework are 10 and 12. Both of those require you to find K. In order to find K, we are given that the population growth of Oregon has grown from 3.4 million in 2000 to 3.7 million in 2006. They are giving you this information because they want you to set up. So let me just write out the formula here. The formula. So the formula right here, we have y equals a times e to the kt. We want to find k. And what we're doing is our initial population was 3.4 times e to the k, and in 6 years it went to 3.7 million. So we can use the information given to find k, our rate. And when you do that, you divide by 3.4 first, then you're left with e on the right side. You ln both sides. So you have ln times 1.088 divided by 6. And you will get that your k equals 0.014. So to answer A, you have y equals 3.4 times e to the 0.014t. Once you do that, you can answer the questions they have for you. What's the population in 2020? When will the population hit 6 million? Right? What are you looking for? Either t, or you're looking for basically the ending. What is the new population? For 12, same kind of start. They're wondering what is k as a constant. You have to kind of do this again. Okay, so maybe pause this video so you can copy this down and use that for 10 and 12. Other than that, good luck. Check your answers on the homework tonight.